Day 17 of 75, and today we kill the linear scan for good. You know binary search conceptually, but in an interview you reach for STD, find, or a manual loop because you're not sure which STL function fits, or you've been burned by off-by-one bugs. By the end of these 5 minutes, you'll pick lower underscore bound, upper underscore bound, or equal underscore range without hesitation. Write an overflow-safe hand-rolled search and binary search on a predicate. 3 skills that separate confident C++ developers from everyone else. Let's go. Start with the trap. You've got a sorted STD vector with a million ints and you call STD find for a value. That's O, N. You just threw away the fact that it's sorted. On sorted data, binary search gives you O log N. A million elements? 20 comparisons instead of a million. The STL hands you 4 tools for this: binary underscore search, lower underscore bound, upper underscore bound, and equal underscore range. Picking the wrong one is the most common silent bug in sorted container code, so let's nail each one. Binary underscore search returns a bool. Does the value exist? Yes or no? Useful, but it throws away position. Lower underscore bound returns an iterator to the first element not less than your value, the first slot where it could live. Upper underscore bound returns an iterator to the first element strictly greater. So for duplicates, lower underscore bound points at the first copy, upper underscore bound points just past the last. And equal underscore range? It hands you both at once as a pair, the entire run of matching elements in a single O log N call. 2 separate calls would work, but equal underscore range says exactly what you mean. Real example, a sorted inventory of pairs, SKU, and name, with duplicate SKUs. You want every row for SKU 420. Call equal underscore range with a custom comparator on the pair's first field. You get back first and last iterators bounding that run, and you can erase the whole range in one shot. That's the full pipeline. Sort once, query in log time, slice the duplicates cleanly. Iterator arithmetic on a vector is random access, so distance between those iterators is O, 1, just like index math. Now the gotcha that fails people in interviews. You have a STD set and you write STD lower underscore bound on its begin and end iterators. It compiles, it runs, and it's O, N. Because set iterators are bidirectional, not random access, so the algorithm can't jump to the middle, it walks. The fix, call the member function, set, lower underscore bound, that uses the tree structure and stays O, log N. Same name, completely different cost. Rule of thumb, if the container has its own lower underscore bound member, always use it. Sometimes you roll your own, a raw array, a weird comparator, raw speed. Here's the invariant version. Low equals 0, high equals n. While low is less than high, compute mid. And do not write low plus high /2 on a large array that some overflows a 32-bit int and wraps negative, and your search silently corrupts. Write mid equals low plus high minus low divided by 2. Same result, never overflows. If ARR, mid, is less than target, low becomes mid plus 1, otherwise high becomes mid. When the loop ends, low is your lower underscore bound. The half-open interval keeps the off by 1 from ever appearing. Last skill, the one that wins hard problems. Binary search doesn't need an array, it needs a monotonic predicate. Say you've got n tasks with integer costs and a budget cap, and you want the maximum number you can complete. The answer space is 0 to n. Write a feasibility lambda. Can I finish k tasks? Sort the costs. Take the cheapest k with a prefix sum. Check it fits the budget. Feasibility is monotonic. If k works, k minus 1 works. So binary search the answer. You're searching a concept, not a container. Same pattern cracks rotated array search and min-max allocation. Day 17 done. The takeaway. On sorted data, lower underscore bound and upper underscore bound give you position, equal underscore range gives you the whole duplicate run, member functions beat STD. Algorithms on tree containers, and mid equals low plus high minus low over 2 is non-negotiable. And when there's no array, find the monotonic predicate and search the answer. Subscribe for day 18, where we take this into two-dimensional search space. See you there.